All right, let's take a look at example 5 now. So we're back to no freebies in this one. So we got to decide which variable to eliminate. So as I'm looking at my different variables, things that jump out at me, those x's don't look bad, but the 7 looks kind of ugly. It's going to be kind of tough to get rid of him. As I look at the y's, I do notice that the 2 and -2 work out really nicely. Not a big fan of the 9, but I can deal with it at least. Now, as far as the z's, everything's ugly over there. I'm not a big fan of anything going on over there. So I think because of the fact that the y's at least had one really easy option, I think that's the choice I'm going to make. I'm going to make my choice to eliminate the y's. And like always, I make my note that I want to end up with 2 equations out of this. So now off in scrap paper land, we're going to look at those 2 ways. Now, one way is I'm just going to add together the first and third equation. Now, I would highly advise actually rewriting it. You want to see this work somewhere on your paper so that if there's errors anywhere, you have a way to look back at your work and find those errors. So I'm copying this down. And then I'm going to add those 2 equations together. That's going to get me 4x 12z equals -20. And this is another one of those situations that everything here is divisible by 4. And so I'd probably do that in this step, is I would say, let me go ahead and divide everything by 4 before I write it over there into my system. So that's going to give me x plus 3z equals -5. Just making my numbers smaller. In the long run, that's generally going to be a good thing. So we've got ourselves x plus 3z equals -5. There's one of my 2 equations that are missing the y. And remember, that was my goal, was to eliminate the y's. So we're partway there. We used equations 1 and 3. So now we need to make sure that we use equation 2. So we need to somehow get rid of that 9y sitting there. So I'm going to have to build him up to 18, I think. So to do that, I'm going to multiply the second equation by 2. In order to eliminate that 18, I'm going to multiply this first equation by 9, because I noticed that the y's are already opposite signs. I could have multiplied the third equation by -9, but I'd prefer to not have to multiply by a negative. I'm less likely to make sign mistakes that way. So, as I distribute the 9 across the first equation, that's going to give me 63x minus 18y plus, holy cow, a big number. So let's see, let's get out a calculator just to make sure. I don't want to be making mistakes in this video and have to re-record the video. So let's go ahead and look at 19 times 9, 171 there. That's kind of a big number, but I want to pause for a second here and point out too, though, we can expect really big numbers when doing these problems because we are multiplying an entire equation by a value, then we're going to add this to another equation. So it's kind of actually normal to end up getting really big numbers when doing these problems. So don't freak out too much until your final answer is something really wacky. So we got -369 as what we're equal to. So again, big number, but that's okay. Now we're going to distribute the 2 across that parenthesis, getting -12x positive 18y negative 18z, and then 57 times 2 gets me 114. We're going to add these 2 equations together, and yeah, those numbers are big, but we can use calculators whenever we want, so that's all right. We're going to get 51x. The y's add up to 0. Now let's go ahead and use our calculator just to make sure over here on our 171 minus 18. We got 153 for our z's. And again, even though this isn't a horrible addition here, let's go ahead and use calculator. We got -369 plus 114. That's going to get us -255. All right, very ugly numbers, I know. But it looks like 51 actually divides into each of these. So just like we divided by 4 over there in our blue situation, we can divide by 51 here. That's going to get me x plus 3z equals -5. And as I write this much simpler thing over here, all of a sudden you can probably see what's going on. Now that we have the same two equations there, this is going to be an infinitely many solution situation. Now we can fully convince ourselves of that if we multiply by -1 on the second equation. So we get x plus 3z equals -5. Negative x minus 3z is +5. Add these together to get 0 equals 0. We have infinitely many solutions. Now let me try to explain in words what's happening here and how that relates back to our lesson intro. When we're getting two equations, two unknowns, what's actually happening here is we're looking at the intersection of two planes for each of those equations, and we're saying, if I just looked in the xz plane, what does the line of intersection look like? So as far as the blue situation, which the blue situation was planes 1 and 3, we see what his line of intersection looks like. Then we look at planes 1 and 2, and his line of intersection is the same. So what that tells us is all three planes share a line of intersection. So all these are intersecting on the same line rather than the same point. That's what's going on here. Now we don't really have to fully understand that as much as knowing if you get 0 equals 0, that's infinitely many solutions. And we're okay with that being the final answer. When it comes to three equations, three unknowns, I'm not going to ask you to write set builder notation. And remember, that's the notation. That's the set of all ordered triplets x, y, z such that something. Because of the fact that we're not going to take the time to describe or to understand when we're getting infinitely many solutions because the three planes are the same plane, or when they're intersecting on the same line, or when two of them are the same plane and one is intersecting at a line. We're not going to take the time to look at all those different situations. So we're okay with saying infinitely many solutions. But be careful here because, like in the last lesson, we don't want to say all real numbers or all ordered triplets or anything like that, because that's not the case. We're just going to say, hey, there's an infinitely many number of solutions. That's it.